Hi, welcome to my channel on JaberTime. Today I'm going to go over graphing exponential functions, and I do have 4 examples. As you could see from here, the exponential functions are written as a times b to the power x, where x is the exponent. B cannot equal to 1, because if you keep multiplying by 1 to the power 1, 1 to the power 2 times 1 to the power 3, it's not gonna go anywhere. It's gonna stay always a times 1, which is horizontal. B cannot be negative, because if you keep multiplying, for example, times negative 2 to the power 1, times negative 2 to the power 3, times negative 2 to the power 4, sometimes it's gonna end up positive, and sometimes it's gonna end up negative, depending on the exponent. Even exponents will force it to be positive. Odd exponents will force it to be negative. So it's gonna keep jumping above and below the x-axis, which is not exponential. And usually the y-intercept is 0, a, unless if the graph is reflected about the x-axis or shifted up or down. So in general, if b is greater than 1, we do have an exponential growth, and a good example will be 2 for the base. And that's how it should look like. If b is a fraction, the best example is, and the values will keep taking you down, as you could see right here, which is called exponential decay. So if b is a fraction, between 0 and 1, we have decay. If b is greater than 1, we have growth. Let's get started. This is a basic graph, or a basic example of 1/2. And you want to keep in mind that anything raised to the power 0 is 1. And when you deal with negative exponents, we have to take the reciprocal or flip it and change the exponent to positive to handle it. Let's plug in some numbers and see the graph. When x equals 0, I have 1/2 to the power 0, which is 1. So the coordinates will be 0, 1. When x equals 1, 1/2 to the power 1, which is half. So the coordinates will be 1 and 0.5. When x equals negative 1, remember that 1 over 2 to the power negative 1, with this rule, is going to be 2 to the power negative 1 down, but I have to flip it, so it becomes 2 to the power 1 on top, and that's 2. So negative 1 takes me to 2. When x equals 2, I have 1/2 to the second. 1/2 times 1/2 is 1/4, or 0.25. Negative 2, again, we have to flip it and make it positive 4 now. So negative 2 takes me to 4. Here's the graph. 0, 1, we could see it. Negative 1, 2. Negative 1 will take me up to 2. Negative 2 will take me up to 4. And decimals right here, as you can see, 1 is 0.5 right there, and 2 will be 0.25. That's like a quarter right there. Domain. Since the graph goes all the way to the right and keeps going this way, there is no restrictions, so we say the domain is all real numbers. The range comes from the y values, and the graph is always positive above the x-axis. We say y greater than 0. The y-intercept, it's this point, 0, 1, and it's on the table. The asymptote, the line that gets close to and doesn't touch it or cross it, is the x-axis, or y equals 0. In behavior, as x goes to infinity all the way to the right, what happens to your y values? The y values gets down closer to 0. As x approaches negative infinity, we're going all the way up, so y goes to positive infinity. So what do we have here? We have an exponential decay, because b is 1/2, which is a fraction between 1 and 0. Second example. Now this one is an exponential growth, but since we are multiplying by 2, it's like it's going to be 3 to the power x, the basic one, stretched vertically by a factor of 2. Let's plug in some numbers. When x equals 0, we have 2 times 3 to the power 0, and 3 to the power 0, because of this rule, is 1. 2 times 1 is 2, and that's going to give me 0, 2, which is going to be the y-intercept, and that's 0a in general. Plug in 1. 2 times 3 to the first, 2 times 3, which is 6, so 1 gives me 6. Negative 1, we have to flip it. So 3 to the power negative 1 becomes 3 to the power 1 in the denominator. 2 times 1/3, 2/3, or 0.6 repeating. 2 will be 2 times 3 to the second, 2 times 9, and that's 18. Negative 2, again, we have to apply this rule. So it's 3 to the power negative 2, it's actually 3 to the second in the denominator, which is 1/9. 2 times 1/9, 2/9, which is 0.2 repeating. Let's see the graph. 0, 2 is right there. That's this one. 1, 6. Here's 1, and here's 6 up here. 2 all the way up to 18. That's right there. And of course, the negative 1, 0.6 repeating, a little bit less than negative 1, as you could see. Domain, again, all real numbers. Range, y greater than 0. Y-intercept, 0, 2. The asymptote will be the x-axis, or y equals 0. In behavior, as x goes to the right, to infinity, y goes to infinity also. As x goes to negative infinity, y goes to 0. So now this is an exponential growth because b is greater than 1, which is 3. Example number 3. This is an exponential growth but reflected about the x-axis and shifted up 2 units. So we have to be careful about the y-intercept. We cannot read it from here. When x equals 0, we have 1 right here with the negative outside. So it's negative 1 plus 2, and that's 1. 0, 1. The reason why it was shifted up is not 0, negative 1, as a is negative 1. When you plug in 1, you get negative 1. That's negative 3 plus 2. When x equals negative 1, we have to flip it. And 3 to the power negative 1 is 1/3. So we have negative 1/3 plus 2. That's like 1 and 2/3. It's like you have 2, but you're taking away 1/3. So it's 1 and 2/3, or 1.6 repeating. 2. That's going to be negative 9 plus 2, which is negative 7. Negative 2, that will give me negative 1/9 plus 2. Differently, I could say 2 take away 1/9, which is 1 and 8/9, which is 1.8 repeating. Here's the graph. So we do have 0, 1. We have 1, negative 1. That's right there. And I do have 2, negative 7. That's right there. That's good enough. Domain, or real numbers again. Range, since we are below 2, because we're always deducting some amounts from 2. So we're always below 2, and the asymptote will be y equals 2, and the y-intercept 0, 1. So here's the range. Y less than 2. The y-intercept 0, 1. The asymptote will be y equals 2. That's this line right here. In behavior, as x approaches infinity, we're going down to negative infinity. as x approaches negative infinity all the way to the left, y goes to the level y equals 2. So y approaches 2. So we have an exponential growth, but reflected about the x-axis and shifted up 2 units, as we mentioned earlier. Example number 4 and the last example. 1/4 to the power x, but with negative up front. So it's just like the first example, exponential decay, but reflected about the x-axis. Take your time, plug in some numbers. 0. 1/4 to the power 0 is 1. With the negative outside, that's -1. So 0, -1. 1. 1/4 to the power 1 is just 1/4. Negative outside, that's -1/4, -0.25. -1, we have to flip it, becomes 4 to the power 1, and that's just 4, with the -4. 2, that's 1/4 to the second, which is 1/16. Of course, the negative outside does not cancel, or -0.0625. -2, we have to flip it, becomes 4 to the second, which is -16. Here's the graph. We have 0, -1 up here. We have -1 and -4 down here, and -2 all the way down to -16 right there. And of course, those small numbers. Domain, all real numbers. Range, since we are below the x-axis, y less than 0. Y-intercept will be 0, -1. That's this point. The asymptote will be the x-axis, or y equals 0. In behavior, as x approaches infinity, the y values are approaching 0. And as x approaches negative infinity, the y values goes all the way down to negative infinity. So what you have here, we have an exponential decay and reflected about the x-axis. That should do it. Thank you, and I'll see you in the next one. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.